Our next speaker is Inácio Henrique Llano from Brazil. Mr. Llano, we can see you. This is good. So I'd like to introduce Mr. Llano. He currently works as an analyst of communication networks and information security at Embrapa Digital Agriculture. Embrapa is the Brazilian Agriculture Research Corporation. And he also works as a professor at the Faculty of Technology of Santana de Parnaíba. He holds a PhD in agricultural engineering. He has a master's degree in telecommunication network management. He graduated in economic sciences and technology in data processing. And he works with topics including machine learning, digital image processing, blockchain, which we already heard, energy conservation, computer networks, and wireless sensor networks. Mr. Llano, we are looking forward to your presentation, and the floor is yours.
Thank you for the announcement. Can you hear me?
We can hear you.
Okay. Good afternoon. I will talk to you about work that we made 4 years ago. I have to click in the internet, click it again because I lost my presentation. Wait a minute, please.
Sorry, yes, you can see. We can see this presentation.
You can see my presentation.
Sorry? You can't see the presentation? Your own presentation you cannot see?
I can see I can see the very small. It is in the left corner of my browser, and can see it in the entire page. I don't know what happened here.
Which is connected to our technique. Oh, I'm just looking to our technician. He says he cannot see any problem. So
Okay.
can you try something?
You can see my first slide.
Yes, we can see it very clearly. So just maybe try to skip one, to go one slide further, then we can, at least we can see, and you know your presentation, maybe, can you go one further? Just to check.
I clicked to forward, but did you change the
first slide.
The slide?
Can one slide further? Can you slide 2? Is it possible?
I am clicking in the green button, but it seems that it is not changing. It is changing for you?
Okay, then just say next slide. Okay, I thought this was already heard. Okay, now it's the second slide. Do you see it?
Okay.
Yeah.
Okay. So the work I will present is the, as I said, was made 4 years ago, and it's about a prototype of a non-genetically modified soybean tracking system using blockchain technology. It's most about traceability system and then GMO or non-GMO. This presentation was divided into 5 parts. Firstly, I will say something about GMO non-GMO marketing. After that, I will tell briefly, something briefly about blockchain technology, and then I will show the soybean track system, and after that, the results and then conclusion.
If you want the next slide, then just say next slide, please, because we do it from here.
Okay, next slide, please. Okay, GMO soybean has low cost production, but some people argue that this GMO soybean can cause allergies, and there is not a long-term study about it is in human health. So there is a specific market for non-GMO soybean, and they pay a bonus for this production. But there is some difficulty to produce non-GMO soybean. We must manage crop isolation to avoid a mix of genetic modified soybean to the non-GMO during the cultivation. Also, we need controls to avoid the contamination. These controls will be done in the transportation and shipping the non-soybean. And as was presented in the previous presentation, the most production is GMO soybean, so there is no much availability of non-GMO seeds. Next slide, please. So this work proposes a non-GMO soybean tax system using blockchain technology. And this tracking system will trace samples, test samples, and the information about the planting, passing through controls on cultivation, harvesting, and transportation to market delivery. And next slide, please. Blockchain is a well-known technology because of the Bitcoin, but it can be used in many other applications. Blockchain has many security issues, like it is maintaining across peer-to-peer computer network, so it doesn't have a unique point of fail. Blockchain, the information stored in blockchain is immutable. The information is has an immutability property. So we cannot change the information when it were stored in blockchain. And next slide, please. Blockchain is a chain of blocks of information. So they were storing, and the last block has the information of the current information and the hash code of the previous block. So this hash code will link one block to another block. And next slide, please. Inside the blockchain, we have the smart contracts. And the smart contract seems like a computer program oriented by events. So when these events happens, it automatically trigger some procedures. Because of this, a smart contract can reduce forgery and it increases accessibility. And next slide. Smart contract make blockchain suitable for many areas such as supply chain, e-commerce, tracking system, Internet of Things, data science and machine learning, legal contracts, and many others. Next slide. Um, 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 Blockchain, we choose blockchain because it is secure against tampering, generate reliability for auditors and consumers. So, and in the next slides, we will show the tracking system, the work breakdown structure, and the smart contract of this system. Next slide. Here we have the data flow of the system. So the soybean production information and PCR test results will be inserted in a block. This block will be compressed in a hash code, and this hash code will be used to identify a website of this information of this specific production of this block. The URL of this specific site will be coded in a QR code to facilitate the access via mobile device. Next slide, please. So this slide show how the blockchain works. We have the information and PCR tests inserted to a block. This block is compressed in a hash code by a cryptography algorithm that makes like a kind of word with fixed length, and the hash code will be used to access the website of this information, like I said before. And also, this hash code will be inserted in the next block together the information of the next block. And this hash code inserted in the current block with the information of the current block will be extract another hash code, so and so on. Because of this, if there is any change of information in one part of the chain, this will make a modification in the hash code of the all following blocks. This makes the security of the blockchain technology. Next slide. Here we have the network diagram of the system. The system will use 3 servers. The web server will make interface with the users, and the users can access the system by smartphone, PC, notebook, tablet. And this application on the web server will store information on the blockchain server and in database server. And the database server is used because it's easier to take information from database than from the blocks of the blockchain. Next slide. Here we have the WBS of the system, and the system was divided into 5 stages. The first procedure is the data definition. In the data definition, we have all the data that will be stored in the blockchain. The next 2 procedures, seed control and field inspection, were made to register the crop isolation. The seed control is to avoid planting GMO with non-GMO in the same crop. In the field inspection, next slide, please. Next slide again. In next slide again. In the field inspection, some controls will be done to avoid to detect possible contamination. And in this procedure, sampling during the growing season we will be taking, and visits with cooperative technician and the auditor will be done in the crop, and leaf test with SGI trait will be made regularly. Next slide. Another procedure is the recipe control. And this recipe control is to avoid contamination by remaining by GMO seeds in the truck. So they must be unloaded before. And in this procedure, PCR tests will be performed. And this for all vehicles. And these tests, these samples will be stored for 90 days, so they can be done again. Next slide. And the last one is the shipping supervision. In this process, there is this one special over all vehicles, and the inspection of the records, and the monthly will be record of this will be done. Next slide. Here we have the smart contract development. It was done at Remix IDE. And Remix is an open source platform where we can compile, run, and test the smart contract. Next slide. Each procedure at the WS will be a structure or a function at the smart contract. Here we have the data definition structure, where we will store information about seed control, field inspection, receiving control, and shipping supervision. Next slide. Here we have an example of a function, the seed control function, where information about the seed control process will store the information that must be stored in the blockchain. Next slide. So we are going to show the results. These results are the simulation of the system at the Remix, where we can make a deploy for tests. Next slide. Every function after deployment at Remix, every function will have an interface that can be used to fill and store the information at blockchain. Here we have an example of seed control. Next slide. After storing the information at blockchain, we have we have access to a report. In this report, we have information about the status, if the transaction was succeed or not succeed. We also have the hash of this transaction. We have the user. He started the transaction, and we have also the smart contract that received the information. Other informations are the transaction cost, execution cost, every in blockchain. And when you write something, this you have to pay a gas. And we also have the hash of the block that were stored. Next slide, please. Here we have the payload of the block storage, and the information in the rectangular in highlight, in red highlight. We have the information written at blockchain by the seed control function. Next slide. So we have also the simulation of all procedures, all functions, like field expansion, inspection, next slide, ECV control, next slide, and shipping supervision, next slide. And at Remix IDE, we can also query the information stored in the smart contract. And we will have the information used at the simulation written at the blockchain. Next slide. Finally, we have the conclusion. Blockchain is a reality and suitable for application in which the available information needs to provide security to partners and consumers. And this traceability system prototype was developed only on the smart contract, still missing the interfaces, but it's possible to notice its effectiveness. We have also other systems that we made the interface, but in this work we just stopped at the prototype. Next slide. So thank you for your attention. Here is my contact. Thank you again. I finished.